Hello everybody to this course about design pattern, and in this course I'm going to talk about a very interesting design pattern solution called factory design pattern. This design pattern is like the first one we talked about, singleton design pattern, as both of them are creational design patterns. So it is so interesting for the programmer to know about, because it's the first point where we can start for creating object. And with this solution we control also how we create object from classes. So as we talked also in other course about the definition of design pattern are so reusable solution for common occurring problems. So this one also is one of them. And what is specifically the design pattern factory is a creational pattern, as I say, and it gives the same interface to create a new type of object. So if we have, for example, an hierarchy of classes, and we want to give the user, for example, the client here, an interface, a common interface to create different products, for example, product 1, 2, 3, 4, and so on. And this is the design pact. This is what we create, why we created design factory. So we need just one interface to give to the user, to the final user, to create a different type of object. So it's like we encapsulate the creation of the child object, and we give just an interface that encapsulate all different new types. So for example, the vehicle, we have an hierarchy of vehicle, and we have for example different vehicle, and we are going, this is just an example, and we are going to code the same example. So let's take the same example of vehicles. So here we can create a class, an hierarchy of classes for vehicles, and in the end give the user the interface to access this hierarchy and to create different objects. So different object, I mean the different type of object, but all of them are inherited from the same interface, same global, some parent interface. For example, here we create vehicles. Let's create vehicles, and we, for example, just one method to give the description as an example. We can create the constructor first for the class, and also create a method that gives some information, for example, about the child class. So each class should implement this function, so and that can give us its identity. As I said on the course of singleton design pattern, there is no just one way to create to code design patterns. Everyone implement his implementation, can create its implementation, but there is some rules that are common and that should be common for all these different solutions. For example, for the singleton, the main problem is to have one instance, and if your implementation that doesn't resolve this problem, so it is not so useful as I think. And it's the same here. Or if you can create your factory method or factory interface or factory classes, and you can implement it according to your class hierarchies and so on. But the main problem is to respect this constraint, is to have just one interface, and this interface can produce different type of product. This is what we want. For example, we can create some child classes like BMW. It's a car. There is something also interesting here to know is about inheritance. So in C++ we can inherit from different classes, and what is inheritance? It's just like a kind of relationship between classes in design paradigm, in oriented object principle. It's a kind of, for example, we can create an inheritance relationship between class if we can say this is a kind of these things. For example, a BMW, for example, is a vehicle, is a kind of vehicle. It's an inheritance relationship, so we can make an inheritance relationship between these classes. So here we created the constructor of the BMW classes, and we implemented the print method. So the class should give us its identity. So we can say that this object belongs to these classes, to these specific classes. So for example here, the class print for the class BMW tell us that I'm BMW classes. Okay, that's okay. That's so interesting. And the same thing, we are going to create another product. What you should note here, that you can create more than two classes, child classes that inherited from the base class, vehicle base class. But but here we are going just to talk about two types. So to give you the answer about the factory design pattern, this is the most interesting for us now. But you can create other types, and you have each time to synchronize with the user interface to tell the user, to tell the interface that we have this new type. So you can start creating an object from it. We have a new product, as I said. We can, for example, have a Mercedes that can also inherited from the vehicle classes and implement some functions and functionalities, but in the interface for now it can't add, it can't create the user can't create these new types, as we cannot synchronize it, as we cannot implement it in the user interface. This is so interesting also about factory design pattern, is that we can create a new product but didn't give yet the accessibility for the user to use it. This is so interesting also. So it's like we encapsulate the implementation of some product, some new product, and we can each time add it as we want, and we can use it as we want and when we want. So we create our hierarchies of class. So we have vehicles and the global interface, and created the BMW and Renault, for example, as vehicles. And now let's create our factory. This is the main interesting thing. So here is the interface that we give to the user to create different object, different type of product. So We created the factory, so this factory needs a pointer to the vehicle interface, so we can access this class, this interface. So let's let's create a pointer to the class of vehicles, and we can call it vehicle. And now we need the constructor for the factory. So this is the method factory that can create for us a different type of object. So according to some parameters, like here we specify that we can give a choice, an integer can give an integer as a choice, so for the user to create different interfaces. So for example, if in the case 1 we create, for example, BMW vehicle, and in the case 2, as we have just two products, if you cannot just, if you have I give the example of two products, but not that you can have more than one product. And if you have more than one product, you can add it in the factory method. So here, for example, if the user have a choice 1, we create the first class object for the BMW object. And if the user want the second one, Renault product, we tell them to give us 2 as integer, so we can create a vehicle which type is Renault. This is the definition. So here I think we are in the good way for now. We created the hierarchy of our classes, and we created the factory classes that can give us the ability to create different product according to our choice. As you can see here, the user can see the BMW or Renault classes or Renault implementation. He can just see the factory method. So here we need a method that give us this instance of the new created product. So we can add it, and we can use it after. So we create first the factory, and we tell it that we need the first product. Okay, then here we want to create BMW product. You can also use enumeration, so you can see you can not put 1, 2, 3 as integers, or you can just use enumeration, so you can make directly BMW or Renault in the parameters of the factory method, of the factory classes. So, and if we want, and as we mentioned, as we mentioned in the parameters that we want the first product, means we will get the BMW product. So we print it. So let's print it first, and let's compile this and see what we have first. As I said, it's compile. Okay, then we can execute it. Okay, it doesn't. Maybe there is another instance. Okay, something is wrong with our code, so come back to the code and we can see what we have wrong here. Okay, we have vehicle BMW. We have BMW that inherited from vehicle. We have constructor. The same for Renault products. Okay, Okay, let's create another. Let's create the Rono first, and we can come back to correct the problem about displaying. Why we don't? Why print doesn't display the description of the object. So if we want Rono, it's the same as it's the same as we did for the BMW product, and this time we need a factory with the second choice. So we need a factory with a new factory with the second choice. So the factory can create for us. It's not us who create no the object product, but it's the factory class who create the object. As we can see here, we just code something that we just code some code that gives the factory what we want. If we want the first choice or the second product, but it's the factory who charges to create product according to our choice. So compile, we have a lot of errors that we are going to correct. It's about okay, there is a lot of we forget to mention that we have a pointer. Yeah, we have a pointer, and also what else we have conversion. Okay, we forget to mention here a pointer, and also the same thing for the factory, the second one. Yeah, it's okay, it's campaign, and we can execute the factory program. Okay, we have a problem here with displays Rono Amrono for twists, and this is not what we want. As I said, we have something mistaken here, and we're going to figure out what's the problem. Created the factory choice, and okay, we created factory one, and we told them we want the first product, and we create the second one, and we tell we want the second product, and we print both of them. So what should the problem do? It should normally give us the MW for the first object, and Morono for the second one, but it displays the same. It's like we have the same object for twists, and this is not what we want. Maybe something is going wrong with compilation, maybe. But okay, let's compile again and see what we have. Okay, we have the same result. No, this is not the problem. Maybe we have a problem with access. No, public. When we print, it's okay. Factory to okay. Maybe we will need. Maybe our first pointer is still pointing to the same memory place, same memory address. So let's create another two. No, maybe this one. We have two factories. Normally we can use a factory for twists, and I created a new pointer. Should have a pointer updated the first pointer, and no, we don't have access for this. It's Rono its own object which have the access to the print method. So maybe we have mistaken something here in our code, but let's check again. Let's create factory tool and get the object and print it. Why it doesn't give us the result? Yeah, we have a problem with the pointer. Yeah, we need a pointer with a lack of pointer. Well, syntax, also syntax error. And this, yeah, this is a problem of pointers. It's not to our pointing or affecting a pointer to an object. Okay, this is also a problem, and it compares. Let's see again. And we have the same problem. Maybe we have a problem with the method that give us the object, that give us the choice object. So in general, it's just something that we forget here. Let's check again, and we can correct this problem quickly. We have vehicle interface. We have the first object that inherit from the vehicle, and they have the same method. The second one also have the same method, and we have the interface that point to the vehicle interface. And maybe we'll forget something in the factory. Maybe I'm sure about factory classes. We have a problem with factory classes, but why we can't create different object? Maybe we forget something. So yeah, we forget by breaking the switch. Okay, sorry. So this is how we can code a factory design pattern. And if please subscribe, and see you in this next video.